We are now at the LSM 800. So Amanda and I are going to show you how to do Airyscan acquisition and processing. And at this point, you already know how to do normal laser scan microscopy. So that we have done already. So this image is a normal LSM image. And you can see here the set positions from 1 to 35. So it's acquired with 63x oil lens, and it's optimal resolution and the zoom factor 1.3. So it will be comparable to what we can do in the Airyscan, but in the Airyscan we can resolve the resolution. And for introduction to Airyscan, very briefly, I will just show you this PDF, which is also located at the desktop of the Airyscan computer. And in general, so the light is sent to a detector through some lens, some objectives, instead of a pinhole. Normally, in front of the confocal detector, there is a pinhole which you put to one Airy unit, and in this system, it corresponds to reduced Airy units to zero point 0.2. So if you do that normally, you would lose all the light. Here you send a minimum amount of light to a number of detectors. So yeah, very simplified, all these 32 detectors get a low amount of light, which is better resolved individually. And then the software and it can combine all these signals into a better resolved image. This figure shows the blue is a normal confocal, which has around 240 nanometer resolution. Then all these small signals from the Airyscan can be combined to a better resolved image. And back to Zen software, and let's start as we normally do in a smart setup. And we have set up these three colors and used the smart setup for the normal detection. Also, you see up here, LSM confocal. But now we change to Airyscan and select. And the system needs to start up, and the Airyscan detector needs to heat up. Starting at continuous, you can see a tab called Airyscan, and it's super overexposed at this point. I'll just stop it and go through my modes here. When we are doing our imaging in a minute, we will use the optimal resolution, but for setting up the system, we go lower. So this will speed up optimization. One important thing is to crop the area to a minimum of 1.3x, and you also guided here in this point. It says you're not optimally configured, and you can see the details. And here it says the frame size is not optimal, and this set section is not optimal. If I go to 1 or a low crop size, then it also complains that I need at least 1.3. So it guides you to do the right settings. Let's go to 1.3 again. And I increase the speed a bit. When you do two-way scanning, you always need to auto correct the turning of the scanner, but I already did that in the normal scanning mode. And let's go down to the channels. Here in live, we can move around and focus quite fast. And in order to set the light and the gain in the channels tab, you go through the sample. I press now Control and scroll with the mouse, and you can see the histogram down here that this is about the focus plane that gives the highest intensity, and you should of course not overexpose. So check the range indicator, and there's no overexposure here. And do it in continuous instead of live, because then you see the actual settings. So this is all good. And in Airyscan mode, you see the normal detection and also the Airyscan detection. So you have two tabs and also two curves in the histogram. You can see it here. So at this point, the green is fine. And I deselect and do them one by one, otherwise it can be a bit confusing. So this is the red, which is far from the same intensity as the green. So in this case, increase the laser power. You can also increase the gain. And still we're far from overexposure. This is also fine for this purpose. And then we go to DAPI, press continuous, and we have the cells coming up. We can increase the light a bit. And here I just change the display. You can see do it manually or use the minimum maximum. At this point, we have the correct settings for the detector, laser, and so on. And we go up to our detection acquisition mode and press optimal. So this would be optimal resolution for the 63x. So the software should not have this as a point. It will then point out that the section is not sufficient, and we didn't set it yet, so it makes sense. So go to the C-stack and first go to a channel of structure. So instead of DAPI, I select the green. And go live. Then focus to the top of the sample or the bottom, it doesn't really matter. And press first or last. So go to the other direction. Press last. Then it's important to use optimal sectioning for the best resolution or the best C-sectioning. And then we also award it with a optimal configured Airyscan here. And in the live, make sure that you are at the focus point and go to continuous. Then you see the image forming when you are in the Airyscan tab. And if you have selected this detector, then you can see that the detector is now uniform. So you shouldn't start if there are any bright detectors out here. So the first 5 minutes it would need to warm up, and then you would see an image like this if you have a sample in focus. And now we are ready to start a process or an experiment, and it will take some minutes. So this would actually take 15 minutes or something like that. So now the acquisition is done, and you can see it's only acquired for the green channel. which was in purpose because time is a limiting factor here. And you can see going through the set dimension in the Airyscan image. I'll just stop it somewhere in the focus plane. And this was the normal confocal image. It had all the channels, so I'll just deselect these two. And you can have an idea of the difference. So an image like this, normal confocal, and this is Airyscan acquired image. Here I show them side by side. So to the left is the Airyscan image, and to the right is normal confocal image. And to do this, just split the image and drag the images you want to compare. And this is Airyscan acquired image. It's not processed yet. And in order to process, you can do it here on the microscope computer, but I'll not recommend you to do this because it's not the best computer for doing it, and it'll also cost you more because you can do it cheaper on another computer. So computer PC2 has the same software, and you can do all processing parts steps there. I'll just show you here anyway. And you can do it in a single mode, which I will show right now, or doing it just on one file. You can also do it in batch mode, where you select files here and let it run for hours if you have a lot of files. I'll just open single and press Airyscan processing. And here in the Airyscan processing, you need to select an input file, which would be my file 7. And you need to go to parameters to add autofilter, 3D processing. You can do different strength of the filtering. So this is just a default, and you can add more and try out. When you're looking for structures, you can see what works best on your file, and simply press apply. In the process bar, you can see this is only 1% through. Now the processing step is done, and this is still the acquired Airyscan and the confocal image from before. You can see going through it here, you can see the difference. And we can scroll in and see the small structures. And we are not interested in this image actually because it's just the acquired Airyscan. We want to show the processed Airyscan image. So it's this one. You can see the name changes from Airyscan to Airyscan processing. So right now we compare a normal confocal with a processed Airyscan image. And you can have an idea that you will be able to distinguish smaller structures when they come into focus again. And there's a bit of delay from the one to another in the focus, but I hope you get the idea, and most importantly on your own sample. So this is the way to do it, and yeah,